people. One of the things that I love doing with this channel is talking about stuff that you can share with your kids or grandkids. So today we're going to talk about the mysteries of color. And here's two mysteries to start with. Who knew that bananas are really blue? And that the green grass and trees of the world is the color they throw away. As a parent or as a grandparent, how many times have you been asked, hey, Mom, why is the sky blue? That's such a great and very typical question that kids ask their elders. And by the way, you notice that I said, hey, Mom, why is the sky blue? Because what do kids ask their dads? Where's Mom? Yeah, no, I'm just joking. Let's get on to trying to answer for you kids out there and you parents, why is the sky apparently blue? Well, first of all, it's not really blue at all. And if you were on a different planet, the sky would definitely be a different color. It depends on what our atmosphere, and our atmosphere is made up of multiple gases, depending what the gases are, and when the light comes through it, the atmosphere absorbs and scatters different colors. So here on our wonderful and only planet we have called Earth, our atmosphere, when the sunlight comes through it, the longer wavelengths, the kind of red wavelengths or the yellow wavelengths, go right through. But the very short ones, like blue, get scattered by the molecules of the gases in our atmosphere. And that scattering makes a blue haze everywhere. The red ones just come through, but when we look up, we see this scattering of the little guys, the little blue guys, everywhere by the molecules in our atmosphere. And that blue light literally being twinkled around by hitting the molecules and just bouncing around gives the impression that our sky is blue. And that's because the light has been split up a bit by hitting the stuff in our atmosphere. Just tell them it's blue because white light gets scattered by the air. And I always like to have a bit of a personal story, and often it's about my dad. And this is another one. So my dad really wasn't highly educated. He was an extremely smart guy, but he didn't go to university. And his font of all knowledge was this ancient book. I think I've got a copy. I mean, it's like, you know, a book like this, full of brown pages with old science information in it. And it was fantastic. I mean, I really enjoy it, but it's a bit old now. But it was an encyclopedia from the 1920s. He probably got it from his dad. Sadly, I never met my grandfather. Can you believe it? He was a scientist and an inventor. He worked as an electrical engineer in the potteries in Stoke-on-Trent. And there are many inventions that he did to make ceramics. He also invented some ointments. I wish I'd met him. But he really helped my dad with science. And obviously he pointed him towards these old books that he had in his library. So when my dad had a question from me and my sister, the kids, like, hey, Dad, is water blue? I remember this. My dad would go, yeah, it's blue. Water is really blue because it says so in the book. And I always thought, nah, it's just some old guy talking and it's not really blue. You can see water is transparent. But today, I'm going to say that he's right and try and explain why water appears blue. So have any of you been scuba diving? and gone down maybe more than 5 or 10 feet into the water and looked up, you distinctly see that the water is blue. And if you say had a red scuba diving outfit on, you would notice that that red color was getting more purpley and bluer as the deeper you got, and the red disappears and turns into this muddy brown color. Really interesting. What's happening? Well, it's very similar to why the sky's blue. White light hits the surface of the sea and goes down, this time percolating down through the water molecules. And in this case, the longer wavelengths, the red light, let's just talk red and blue, simplify it, the red light tends to get absorbed higher up in the water. It just goes. But the short guys, the little guys, the blue, high energy blue light, tends to come down deeper. So the deeper you go and the more water you've got above you, the bluer the light that exists. There's only blue light down there. The red's gone. So deep down under the water, and you're looking up, water appears to be blue. The old theory, and I think this is also kind of interesting, that there is a theory, and I think this has been proved, and I've never seen a picture of it. If you've got a big enough tank of water in a white box, water would appear blue. But is that because you're seeing the red light being absorbed and you're looking at the water, say, from above on this big white box, and you're seeing water looks bluish, or is the H2O blue? I think it's about the absorption of color. But if you're a color scientist or a water scientist out there, tell me what you think. But basically, the sky is blue and water's blue because of the absorption of the red light. Now we're going to have a quiz. This is a great quiz and something I never knew. I'm going to show you some butterflies. How many of these butterflies are blue? Well, obviously the answer is they're all blue. But in fact, they're not blue at all. If you look at their wings, the feathers, they have kind of tiny microscopic feathers in the butterfly wings. Under a microscope, under white light, their wings are white. Why they appear blue to us is because the feathers in their wings are so fine that they filter out all the other colors, and all we're left with this incredibly fine grid is blue light. So they've adapted their fine feathers on their wings to make them appear blue. That is just fantastic. And here's something amazing about the word and the color blue. Did you know that there's cultures and languages on our planet today that don't have a word for the color blue? Blue is often ignored in certain cultures. They just don't see it as a unique color. Why do you think that might be the case? Let me know, because I really don't know. And so to end, I promised to tell you why a banana is blue and why green is not necessarily the color of life. We perceive colors with our eyes, and color is often just a reflected color. It's what's left over after the object has absorbed all the other colors. So in fact, a yellow banana is in fact a blue banana, but it doesn't want the yellow light, so it throws it out, and that's what you see. You are seeing the color it doesn't want. It wants to be blue. And this is absolutely gobsmacking. The color of life, the green grass, the green trees, the green plants that we associate with health and life of a plant, is the color they throw away. And this is revealed to us all, but we don't kind of get it. In the fall, in the autumn, where plants turn that yellowy red color, that's their color all year because those are the colors that they want. But when they die, they stop the process of throwing away the green. Let me try this in a different way. So a healthy plant wants to absorb the yellows and the reds, and that produces the food in the plant to make it grow. And the color that they really don't want, because it's too much for them, is green light. Green light is just does nothing for them. And in fact, it's the opposite of what they need. So in fact, they absorb out of the white light of all the colors mixed together, plants absorb all the colors that they want, mainly reds and yellows, and they throw away the bit they don't want. And we see that as green. And that's the color that plants throw away. And in the fall, when the plants die, they stop that process and their true color, the true color of the leaf that we're not seeing, is revealed because the chloroform, the green stuff in the leaf, has now gone, revealing the true color of the plant. So in fact, our world is bright red and bright yellow, but we perceive it only as the colors they throw away. The truth is out there.